Hey viewer, come and follow me to where the magic happened. My bedroom! No worries, YouTube doesn't allow for strong pornography. I simply needed a spot large enough to film the start of the project, which by the way is not exactly for the faint of heart. I'm not gonna bore you with all the details of unwiring, rewiring, disassembling and terminating all these electrical components. Besides, I actually don't want you to follow along this particular procedure. Let's say for safety reasons. If you attempt a procedure like this, it's always advisable to mark all your wiring, take a lot of pictures, and be very careful. It's easy to mess something up and forget stuff. However, let me introduce you to the quite possible most radical SV08 mod no one ever asked for. And it actually prints. Before we get into the reason for this drastic change, let's talk a little bit about fan noise, particularly the fan beneath the printer. Everyone knows, and as shown in this video by Gergo, that the SV08 is quite noisy. However, you don't actually have to put a Noctua fan on there or anything like that, because as you can see right here, the fan itself is not that noisy. It's just the path of the airflow that makes it so noisy. To illustrate, listen to this. Most noise comes from this aluminum shield with all these ribs. So if you find a way to eliminate this entirely and mount your fan differently, that is probably one of the better options. But be careful. I'm not saying you should do that because you might expose certain electronics. And as soon as it comes to electrical things, always safety first. But yeah, these ribs, that's the reason for the noise, not the fan. Now, let's explore this abomination of a printer. So, what did I do here? Well, essentially, I went through a lot of trouble in order to move all the electronics from underneath the printer to the top of the printer. Positive side effect is my screen is now mounted on top and very easy to reach when the printer is on the floor. But that was not the reason why I went through all this trouble. It was more like understanding how a printer of this format and this build type based on the Voron would behave if someone would design it upside down. Because if there is the time where I consider building my own Voron, maybe even a larger one like 500 by 500 or 600 by 600, I don't really want to drag the printer around and flip it over or like lift it on a workbench every time I need to get to the electronics or like adjust something with the stepper motors. At the end, it would also be possible to build something like this where the set stepper motors are mounted from the top, and then everything would be accessible from the top through an access hatch in the back. You could still have your, let's say, filament changer reels in the front and then everything else in the back. And it would still fit within this form factor of the 350 cube printer. If you have a larger one, obviously you have more space. Then there's the other consideration. All these electronics, they produce heat. And we just blow air through and it goes into the room somewhere. But what if someone would design a chamber heating mechanism that also uses residual heat from all of these components to assist with heating the chamber? I don't expect them to push out enough temperature to actually actively heat a chamber. But it could make the printer a little bit more energy efficient. Or not. Like, it's just speculation at this point. The other idea I had was If you would have the electronics on top, you could, you could create a heavy base plate. I don't know, like, like an anvil. Might be excessive, but a heavier base plate where you can mount your print bed to, and it gives you a better point to keep the print bed level instead of plastic that always moves a bit, and then you rely on those extruded aluminum rails underneath. So if you give it a heavier base plate, it would give the print bed something more solid to sit on, and also potentially reduce vibrations in the printer. I know, of course, all of that would be completely stupid for shipping. I get that. It is more to understand how a printer behaves if you want to build one in place for your specific needs. Usually the wire comes out this hole, and then it goes up, and then it goes over the gantry, and then it runs up again, and in a loop, and to the print head. And every time the gantry moves, the wire like folds up and down and moves around. The wire is probably fine, but there's always potential for pinching. If you now, like in this case, feed the wire from the top, you could like create some kind of a cam system that the wire is just attached to, and every time the printer goes up, the cam lifts the wire, and the printer goes down, the cam lowers the wire without the wire crunching, pinching, or moving all too much. It would always be supported. Well, but as you can see, this is all very sketchy, right? I mean, I literally used string to attach these wires. It was a lot of work, but I don't want to suggest anyone doing this because it's also kind of dangerous. They are exposed terminals. I mean, I went through the trouble and put a little bit of electrical tape here so that when you switch the printer on, instead of doing this and you might hold it like this, you don't electrocute yourself straight away. Yeah, safety considerations were not exactly the priority here. This has more the feeling of crazy cyberpunk engineer hacking something together in a back alley. And I'm talking about gritty 80s cyberpunk, not the new pink neon light version. Because if I wanted to have that, I just like put a neon LED on my printer and dump a bucket of water on it so that it's always shiny. But that's the reason why I did not exactly show you how I did that, because I don't want to encourage anyone doing this. It is just to get an understanding that it is possible and how it behaves. Also, it had the side effect that now my fan here, which is professionally attached with a zip tie, is way quieter, as I presented earlier. I have to now disassemble all of this again and put it back to standard, because one side effect is that the pressure probe down here for the set offset calibration doesn't work anymore. Either way, I messed it up, or it has something to do that I added like 6 feet of additional wiring, which might increase the resistance, and therefore it doesn't deliver the proper signal to the MCU. I'm not 100% sure how this pressure sensor works, if it is resistance or if it's just a switch. Like, I just gonna go back to the original setup and take all the stuff that I learned from this experiment and think about the future of my 3D printing journey. But that is something for a different video.